In this lesson, we're going to talk about how to simplify a radical expression. So what we have here off to the right side is a radical expression. And there's a couple of vocabulary terms to take note of when we look at this. And we're used to looking at radical signs because we are very familiar with perfect square numbers like 9 or 16 or 25. But now what we're going to be doing is taking the square root of a number that's not a perfect square. So a couple of vocabulary terms. First of all, the number underneath the radical is something called a radicand. Sometimes it can be called the argument of the radical. And then the little number that you see that's kind of like between the little tail here of the radical, that's called the index number. Now, we're used to looking at square roots where there's no number actually there. But starting with 3 and moving to 4, 5, 6, and so forth, you'll have this number called the index, and it'll tell you what root that you're taking of the number. So in our case, we're taking the cube root, or the third root of 125. Okay, so when you're simplifying radicals, there are 3 big rules that you have to follow. And all of these must happen in order for the radical to be simplified fully. We're going to focus on rule number 1 today, which is why I circled it in red. And the rule is the radicand has no perfect square factors other than 1. I'm going to show you what that means in just a moment. The other 2 rules that must be followed, number 2 is the radicand contains no fractions. So you can't have something like this. You can't have 2 over 5 underneath the radical symbol. It's not allowed. We'll talk about that a little bit later on in the unit. And then number 3, no radicals appear in the denominator. So you can't have something like 2 over the square root of 5. That's not allowed. So we're going to talk about that a little bit later on as well. All right, so let's go ahead and take a look at how to simplify a radical. Like I was saying earlier, we've talked a lot about perfect square numbers like the square root of 36 or the square root of 81. And we know that the way that you get the square root of a number is you're trying to find 2 numbers that multiply to give you that number. So 6 times 6 will give us that 36. And 9 times 9 will give us that 81 that's underneath. So it's a little bit different when you're working with a number that's not a perfect square. So let's take a look at the example, the square root of 72. So there's a rule that we have to know in order to simplify this radical expression, and it's called the product rule. And the product rule states that the square root of a times the square root of b is equal to the square root of ab. I'm going to show you how that actually looks in a problem here below. So let's go ahead and follow these steps to go ahead and simplify the square root of 72. Step 1 is going to be to find 2 factors of the radicand. So I want 2 numbers that multiply together to give me 72. And in this case, unlike the perfect square number, they don't have to be the same number. So I'm going to use the number 2 and 36 because I know that 2 times 36 gives me 72. So what I'm going to do is now that I have found my 2 factors, I'm going to do step 2. I'm going to break up the radicand using multiplication. So I'm going to say the square root of 2 times the square root of 36. Now what you can see here is the product rule in just happening as you can see here. I have the square root of 2, which we could say is the square root of a, times the square root of 36, which we can say is the square root of b. And if we multiply them together, they're going to give me the square root of 72. So basically it would look like this. Don't write this down if you're taking notes, but basically it would look like this. If I multiply 2 times 36, that'll give me that square root of 72. That's the product rule. So now I'm just going to go ahead and erase that part because that's actually not part of the problem, but I wanted to kind of show you what the product rule was. Okay, now what we want to do is simplify all other radical expressions. That's step 3. So we look back at square root of 2 and we see that it cannot be simplified. We can't break that down into anything other than 1 and 2. And if I ended up breaking it down into 1 and 2, we wouldn't be able to break it down any further. So we'd actually end up doing the product rule again and simplifying it back up to the square root of 2. So we have to recognize that you can't break that down any further. So I'm just going to erase that, and I'll show you what I'm going to do. I'm going to rewrite it. I'm just going to rewrite it as the square root of 2 because it's already simplified fully. Now the square root of 36, on the other hand, is a perfect square number. And I know that that is equal to 6. So I'm going to simplify it to 6. Now that both of my terms are simplified, I'm going to rewrite it with the coefficient out front. And there you have it. The square root of 72 equals 6 square root of 2. Oh wait, let's do a couple more of these. I'm going to show you something cool here in the calculator now. So this is going to be really helpful to you as you try to find these factors. So as the numbers start getting bigger and bigger, you're going to notice that it might be a little bit harder to find the two factors that multiply to give you that number. So in your calculator, if you go to your y equals and you put whatever the number is underneath the radical, in our case it's 128, go ahead and put 128 and divide it by the variable x. Then you're going to go to your table of values, which is second graph, and you're going to have an x and a y column, just as I do here. That x and y column, well, those contain your factors. So you can see that I have all the factors of 128. Some of them are nice numbers and some of them are not. So the point I want to show you here is you're always in search of the largest perfect square value. So you can see that I have two circles here. I have 2 and 64, and I have 8 and 16. Notice how 64 is a higher perfect square number than the number 16. I'm going to show you two examples here below using these two factors, and I'm going to show you the difference between using the lower perfect square number versus the higher. So let's go ahead and use the higher perfect square first, the 2 and the 64. If I break 128 into the square root of 2 times the square root of 64, I look back at square root of 2, and he is simplified. And I can break square root of 64 into 8. And there I have my answer. Now, I'm going to go ahead and use the lower perfect square value, that's 16. I'm going to break my 128 into 8 and 16. So you can see that 8 can also be broken into 4 times 2. And the square root of 16 is going to be 4. I have to take one more step and simplify everything. Square root of 4 is a perfect square, and that's going to be 2. The square root of 2 is simplified, and 4 is simplified. So I had to put it all together. 2 times 8 would give me 8 square roots of 2. Obviously, I'm going to get the same answer, but you can see that when I found the higher perfect square number, I got to the answer a little bit faster. So in your calculators, you really want to try to find the highest perfect square value in order to get to that answer faster. All right, let's try a couple examples. Let's try 180. Go ahead and try to go in your calculator, go to your y equals, and take 180 and divide it by x, and just take a look through your perfect square values. I came up with 5 and 36. 36 was the highest perfect square number that I saw there. So let's go ahead and break it down. The square root of 5 is already simplified because I can only break them into 1 and 5, which would end up, I'd have to do the product rule and bring them back to 5. So square root of 5 stays the same. Square root of 36 gives me a 6, and I'm going to rewrite it with my coefficient out front, 6 square root of 5. And I have simplified my radical of 180. All right, let's try 192. 192, go ahead and put that in your calculator and see if you can find the perfect square that's the highest. And it looks like I found 3 and 64. So 3 times 64, square root of 3 is simplified as the square root of 3 times 8. So I'm going to rewrite it as 8 root 3. Okay, now this one's a little bit different, but I'm still going to treat it pretty much the same way. This time I have a number out front. All that means is that I'm going to be multiplying it, my radicals by 2, which is fine. So go ahead and put 384 divided by x in your calculator. And you can go ahead and take a look and see if you can find any perfect square values. And I see 64 there. So I'm going to say the square root of 6 times that 64. And I'm going to go ahead and break him down. 2 times, now you can see that I could break down 6 into root 3 and root 2, but that would end up being the product rule as well, where I have to put it back up to the root 6. So simplified is just going to be root 6. And I'm going to multiply that by 8. So if I multiply 2 times 8, that'll give me 16 and root 6. And I have simplified my radical. Okay, same thing with my negative here. I'm just going to bring my negative 3 straight down, and I'm going to go figure out what my factors are for 512. And again, I'm trying to find nice perfect square values. And again, I have 64, I notice. And I might have another one that's higher. Yes, 256. So I have the square root of 256 and 2. So I'm going to multiply it by 2 and 256, which is a perfect square number. So I'm going to have negative 3 times square root of 2 times 16. All right, so now I have negative 3 times 16 will give me that negative 48, and I'll bring down my root 2. Okay, so that's how you simplify radical expression. And we're going to go ahead and now we're going to add some letters in there. We're going to add some variables. So this is kind of cool. All right. The first thing is this little chart here above. I'm going to go ahead and show you what it looks like to simplify variables. And these are just things that you'll want to commit to memory. And the more you do them, the more natural it will be as you work these problems. So the square root of x is going to be simplified as the square root of x. The square root of x squared is going to be simplified as x. The square root of x cubed will be x root x. The square root of x to the fourth will be x squared. Maybe you're starting to see a pattern right now. X to the fifth will be x squared root x. And x to the sixth will be x cubed. And you're probably starting to see a little pattern with these. And that leads us to the idea of higher powers. What happens when you have something like x to the 20th or x to the 9th? Well, if you notice from the box here, we have a pattern going on. First of all, let's look at even numbers. Even numbers have higher powers. What you're going to do is you're going to divide the power by 2. So, for example, the square root of x to the 14th is just going to be x to the 7th. It's pretty easy. X to the 20th will just simplify to x to the 10th. Now, odd numbers. This one has a little bit more thinking to it. So what you're going to do is you're going to subtract 1 and then divide the power by 2. So in this case, I have x to the 9th. I would subtract 1, which would give me x to the 8th. And then I would divide the power by 2. So I'm going to have x to the 4th, and then I'm going to tack on a root x at the very end. Let's try another one of those. X to the 15th. I'm going to subtract 1. That's going to be x to the 14th. I'm going to divide it by 2. That's going to be x to the 7th. So I'm going to say x to the 7th root x. Okay. This is going to take a little bit of time to really process these, and but feel free to, as you write these down in your notes, to flip back and look at these as you're working through the next couple of problems. All right, so now we're going to simplify the expression with variables. So the first thing I want to do is I kind of want to do the product rule in reverse. I want to break this radical down into 3 parts. First, I'm going to break it down into just the constant number 50. Then I'm going to break it into x cubed, and then I'm going to finally break it into y squared. That's where you want to start. So you're basically, again, you're doing the product rule backwards. Now let's take each piece and treat it separately. So the square root of 50, I know that that will break into the square root of 2 and the square root of 25. Great. Now I'm going to keep moving from left to right, just like I'm reading a book. I'm going to go ahead and simplify the square root of x cubed. That's going to be x root x. And then I'm going to simplify the square root of y squared, which is going to be y. All right, I'm going to go back to the beginning now, and I'm going to simplify anything that hasn't been simplified. So the square root of 2 is simplified. Square root of 25 is going to move into a 5. And then I've already simplified these guys, so I'm just going to rewrite them. And now I want to write them in the proper order. The proper order is the coefficient first, then everything that's outside of a radical. So x, y, and then I'm going to say my radical to x. And that is my simplified expression. Okay, let's try 28a to the 4th, b to the 5th. Let's start off by breaking it into root 28, root a to the 4th, and root b to the 5th. And I'm going to go find my calculator, or you can, you might know this one right off the top of your head, but you're looking for a number that is a nice perfect square number. And in this one, it's actually kind of small. It's 4. So 4 and 7. And then let's go ahead and break down a to the 4th will just be a squared. And then b to the 5th will be b squared and then a b. All right, let's go back to the beginning and simplify anything else that we can. 2, the 7 is already simplified, a squared times b squared root b. Now I want to piece everything together. I'm going to do coefficients and outside numbers first. So 2a squared, b squared, and then my radical symbol, 7b. And I've simplified my expression. Feel free to pause the video and try these on your own if you like. Okay, let's do the next one. Let's go ahead and try to break this up. So I'm going to do 32 and then root m to the 8th times root a times root g to the 7th. And I'm going to go ahead and look at the number 32. And 32 is a nice number. It's going to break into 16 and 2. M to the 8th. Well, it's a higher power, so I'm going to look at it. It's an even number, so I'm just going to divide it into 2. That's going to give me m to the 4th. The square root of a is just going to be the square root of a. And g to the 7th, it's an odd number, so I'm going to subtract 1 to give me 6, divide it by 2, so that's going to give me x to the 3rd followed by a root x. All right, I'm going to go back to the beginning and just simplify anything else that needs to be simplified. So 4 root 2 times m to the 4th times root a, and these guys are already simplified. So let's piece it together. 4 m to the 4th x cubed root 2ax. And you might be wondering, is there any particular order to put these letters in? Not necessarily. If you want to put them in alphabetical order, outside or inside, that's fine, but not necessary. All right, the last one here. 3 times root 75 times h to the 6th times w to the 9th. Okay, let's go ahead and break this up. 3 times root, let's do 25, yeah? Times root 3. Now h to the 6th, that's going to break into h cubed. And w to the 9th, if I subtract 1, that's going to be 8, divided by 2, that's going to be x to the 4th, followed by a root, I'm sorry, not x, w, whoops, and root w. Let's simplify. 2 times 5 times root 3 times h to the 3rd times w to the 4th root w. Piece things together. 3 times 5 is 15. Then I have h cubed w to the 4th, radical 3w. And there you have it. Okay, so now that we've looked at simplifying expressions and simplifying expressions with variables, let's throw some cube roots in there. All right, the cube root. So the cube root works exactly the same way in the graphing calculator. You're still going to put your number over your x and find your factors. Now, the only thing that's going to be different here is you're no longer looking for perfect squares. You're looking for perfect cubes. For example, the one that I've circled here, you can see that 8. Well, 8 is a perfect cube because 2 times 2 times 2 will give me 8. So I'm looking for numbers like that, like 8 or 27, numbers that will present a perfect cube number. And again, you're trying to find the highest perfect cube number if possible. It's okay if you don't, but it's always helpful if you do. Okay, so what do we have here? We have this cube root of 24. So it looks like I'm going to break that into the cube root of 3 times the cube root of 8. And I know that the cube root of 3 is going to remain as the cube root of 3. And the cube root of 8, like I just said, is going to be 2. So my final answer will be 2 cube root of 3. All right, let's try 108. 108. I'm going to have to use my calculator for this one. All right, it looks like I have the cube root of 4 and the cube root of 27, because 3 times 3 times 3 is 27. So the cube root of 4 does not simplify down, but like I just said, 3 times 3 times 3 is 27, so there we have it. And so 3 with the cube root of 4 is my final answer. All right, let's throw some negatives in there. Negative 192. I'm going to need my calculator for this one as well. And I'm going to need some perfect square values. All right, so it looks like I have negative 64. That's nice, or 64 in our case. Okay. Because 4 times 4 times 4 is going to give me 64. So here we go. Cube root of 3 times the cube root of negative 64. All right. Let's go ahead and do that. All right. So we know that the cube root of negative 64 is going to be negative 4. So I'm going to break that down into negative 4. So that's pretty easy then. Negative 4 cube root of 3. All right. Now, variables. Let's put some variables in there. All right, it's going to work the same way here, but I am going to add one more unique little thing here. So let's go ahead and first just do our product rule and just break things down. So I have the cube root of 162 times the cube root of x to the 6th times the cube root of y to the 4th. There we go. All right, so I want to go and let's work on my number first. So I have 162, and let's see what looks like I have 6 and 27. So the cube root of 6 times the cube root of 27. All right, now let's look at the variables. This is kind of interesting how the variables work. I'm going to I'm going to come down to the bottom here to kind of show you what the variables do. So I'm going to be working with 3 cube root of x to the 6th. What this is actually saying is this. It's actually saying that I have 1, 2, 3, 4, 5, 6. I have 6 x's underneath my radical symbol. Okay, so like in a perfect square number, you're looking for 2 numbers that will make that number underneath. So it's kind of the same way where I want to figure out how many triplets can I make. So 1, 2, 3. This right here is going to make an x. And I know that it's 3 because of my cube. And then I have another set of triplets over here. They're going to make x as well. Once I make that x, it's actually going to be pulled out front. So since I have 2 x's, when I simplify that, it's just going to be x squared. I know that's kind of weird. So I'm going to multiply it by x squared up top. Let me do that again with the y's now. So for the y's, let me give myself some room. I have cube root of y to the 4th. So again, this is like saying that the cube root of y times y times y times y. Let's see how many triplets I can make. I can make 1, 2, 3. So I'm going to take that y and I'm going to pull it out front. If I pull it out front, that leaves me with y, 1 y out front, and then underneath the cube radical, there's 1 y left, which is this one I'm boxing. So that's how you simplify that cube. Let's go ahead and actually finish the problem now. The cube root of 6 leaves me with the cube root of 6. The cube root of 27 will simplify to 3. Everything else is already simplified because I simplified it below. And now I want to piece it all together. So let me go ahead and erase this down here. Okay, so now I have 3x squared y cube root of 6y. And there you have it. Okay, now the last one. I have the cube root of 256. So let's go ahead and break it into its pieces. 256, and then x squared, and then y cubed. And I need to go ahead and use my calculator to figure this one out. Looks like 4 and 64. So I have 4. I'm sorry, these are all cubed. Whoops. 4 and cube root of 64. Okay, let's go ahead and do this thing again. I have the cube root of x squared. So the cube root of x squared is actually going to be the cube root of x times x. And obviously, I can't pull 3 of them out. So I'm actually just going to leave it exactly the way it is. I can't simplify him at all. Unlike the next term, the cube root of y cubed, I can simplify that down because I have 1, 2, 3. I have triplets underneath, which will make a y that I have to actually pull out. So I'm going to multiply it by y. All right, let's go back to the beginning and simplify. Cube root of 4 times 4 times the cube root of x squared times y. Put them together, 4y cube root of 4x squared. And in underneath the radical, you also want to have your coefficient out front as well. Okay, so I believe that is the end of this section on simplifying different radical expressions, both radical expressions that are not perfect squares and working with cube roots and variables.